Yeah.
యాక్చువల్‌గా మనం డెప్త్ అది థిక్‌నెస్ ఆఫ్ ఫౌండేషను మనం ముందే అస్యూమ్ చేసుకోం గదా! హలో!
Like roughly you have to assume something kada. You have to stay at some volume. You can't go from zero, right?
ఓకే. దాని మీద అంటే ఇప్పుడు థిక్‌నెస్ చేంజ్ అయ్యే దాని మీద ఏమంత ఎఫెక్ట్ ఉండదా?
ఉంటది. థిక్‌నెస్ చేంజ్ అయ్యే కొద్దీ కూడా నీకు మెటీరియల్ పెరుగుతది. మెటీరియల్ పెరిగే కొద్దీ డెన్సిటీ పెరుగుతది. డెన్సిటీ
అంటే మనం డిజైనర్‌కి ఇచ్చేటప్పుడు మనం ఎలా థిక్‌నెస్ ఏది అస్యూమ్ చేసుకొనివ్వాలి వాళ్ళకి?
that is designer's responsibility. He will give the thickness to you. Then you
ఓకే.
have to tell that whether it is going to pass or fail.
ఓకే.
That is not the analyst's responsibility, right?
ఓకే.
CAD team will take care of that. You should be doing only the analysis part.
ఓకే. యాక్చువల్‌గా అయితే మనం బేరింగ్ కెపాసిటీ రికమెండ్ చేస్తే దానికి తగ్గట్టు వాళ్ళు థిక్‌నెస్‌ని చూసుకుంటారు గదా! యాక్చువల్‌గా అయితే.
See, if you want to start from a position, you should have some rough thickness with you.
ఓకే.
You start with that rough thickness and you understand the behavior, whether it is failing or it is withstanding for the load.
ఓకే.
Okay, so for this particular thickness, maybe the design team expected a deformation of something around 0.02 meters or like 0.05 meters, but that not happened. Maybe you stopped at like 0.01 meters itself for the load applied. Then you can suggest to the design team that you can come down the thickness.
Okay.
But to start with something, you should be start with some position that you have to assume it. That based upon your past experience or your company requirements, anything.
Okay.
Yeah, Vivek.
How can we calculate bearing capacity of soil like we calculated the settlements in the previous?
Your voice is not clear for me, Vivek. Is the same for all?
Yeah.
Just a second.
Hello.
Yeah, Bharat.
Suppose if I give more volume of load, that means the soil will collapse. Hello. Which criteria it will take? Generally, we have two criteria, shear criteria and settlement criteria.
Combined together, it will take it up. But if you would like to see in which direction it is failing, then you have to dependent on the directional stresses.
Okay. How can I predict the maximum amount of load that the soil can take?
That's where actually still I need to come up. There is one analysis called as a safety analysis. If you see now, you are calculating only the plastic analysis, right?
Yeah.
So there is a thing called safety analysis. If you put that safety analysis, then it will gives you the factor of safety.
Okay. In later class we will cover that, right?
Hello.
Okay. వచ్చే క్లాసుల్లో ఆ టాపిక్ కవర్ అవుద్దానా?
Yeah.
Okay.
So once if you know the factor of safety, let's say that today that you are designing something, and if it is failing, that means the factor of safety is less than 1. Okay. And if it is passing, up to like what extent it can be passed at, either it can be a 1.1, 1.2 or 2.1. So okay. I want to know that particular criteria also. So for that you have to do the safety analysis.
Okay.
Yeah, Ashok, you are asking something. Bharat, if you are speaking, you are on mute. Sorry, Vivek, if you are speaking, you are on mute.
Sai, I am asking.
Yeah.
How can we calculate the bearing capacity of a soil for a given footing?
That is what just now I told, no?
What can you repeat? I wasn't there. Actually, I was searching my headphones.
Okay, okay, fine. Yeah. See, when you just wanted to know the maximum capacity of your soil for the applied amount of a load, or like to which load it can able to bear that particular thing. So to know about this particular part, we have to do a one extra analysis called as a safety analysis. So right now you are doing only the plastic analysis. So the next we have to go for a safety analysis. The output from this particular safety analysis is like it gives you like what is the factor of safety for your particular design. Let's say that if your factor of safety is something like a 1.1, but you need to but your target is something like a 1.4, then you need to improve that particular design and all. But if it is beyond more than 1.4, then it will show you that it is 2.1. So based on that, you can able to understand what is your bearing capacity.
Okay, okay.
Okay. Ashok, do you have something?
Oh, sorry. Carry on.
Oh, yeah. So Prabhakar sir, do you have anything to ask?
No, sir. I'm listening.
Okay, fine, good.
No, no.
Guys, but I just look into the analytics of video viewing. You guys have downloaded and watching, that is really good. But to the number of hours that you are spending on this particular videos are like very less actually. So please, I'm just hinting you again and again. You can download it also from the YouTube, and then if you wanted to watch it, you can watch it from there. But please be make sure that watch the videos of multiple times and practice it more. Only I'm telling you that I got a feedback that I'm going fast, but when you just look into the any training across the world, I'm challenging that no one will go this much slow for especially on Plaxis. Okay, Plaxis is a very expensive thing, and people will only look for the money at that particular point of time. Even I used to do the trainings for 2 days of a training. I used to charge 75K per a student. Okay, where I'm just going to tell very simple things. If you feel that I'm going fast, that means you are not watching my videos properly. Please watch the videos again as to the class. If you hear it once, you will never remember that. You have to put this effort for the first 10-15 classes only. After that, it will be like a cakewalk for you.
As I have seen, you are going into very much detail at reasonably low speed, not high speed. I can't agree.
Yeah,
Now, I'm
but
going
Because
with
I
for
a
me
have,
very
also
slow
it
speed
will
actually.
be
I have arranged the
same load.
Plaxis program for my student, and almost nobody could catch anything. But as you said rightly, repeated viewing of the video is clarifying many doubts, and then it is possible. Because at some point of time while you are talking, we miss something. I agree. It happened to me also. But when it is when I repeated viewing to that, definitely my doubt is clarified. So at the same time, action is also needed. That is the second point. That's all I want to say. Thank you very much.
Excuse me, Sai.
Yeah, Vivek.
Uh, can you just open that problem of flexible footing you did in last class? And can you please show the reached values for that?
Yeah, sure. I'll do that. Hmm. Anything else? I have a plan actually. As per the plan, I will go. I will cover that particular topic also. Just make it in your list. So when I clear that, you can just tick mark that.
Okay.
Okay, fine. Moving on. So how many of you have practiced it on the excavation part? Did you try it or not?
I couldn't do.
Fine. The others. Yeah, Vivek, tell me.
in the last of that excavation partner, you did like first you assumed a particular area, then you cut off that, and after applying the calculations, you changed that area and that. Can you please explain that again? I was little bit confused at that part. That
That is where
how
I'm
are you?
giving you the recorded videos. Please go through the recorded videos. How many times you watched my last video? Can you please tell me?
I watched it 2 times.
What is your exact doubt? You just mark it, put it as a sentence, and then give it to me. You want me to explain the whole problem. That is what the problem. But if you struck at particular position, I'm really happy to help you on that. If you watch
Okay,
my
should I write?
video and if you have a
Yes,
doubt
yes.
on the whole problem,
No, no,
then
not the whole problem. Just the end part.
the end part, what is your doubt? Can you repeat again?
How did you selected that part to be cut off, and after that you changed that area, and you said that area will be excavation will be much less from earlier you selected I think for 5 meters or 4 meters. Then after that you changed it from that to 1.5 meter, I think.
Okay. That's again, okay. I recommend you to watch my video again, but
Okay.
the same thing I'm going to repeat it now. Just because of you, I'm just repeating the same thing, which is going to occupy the half an hour of time. But I'm repeating that for you. So I recommend you to do that. Please keep on watch my videos on regular basis and all. Okay.
Okay.
So hope you
You
guys
can
can see
you
my
can
screen, right?
Yeah.
Okay. If you see my screen actually, so there actually the first thing. Let me do this. Okay. Uh, not jump to this actually. Activate this particular soil to as well, and I don't want this particular phase. Going to the structures module. So the unnecessary structures I'm deleting it, and this is also I'm deleting it. Now going to the meshing module. Now in the meshing module, I'm just generating the meshes again. And if you just go to the stage construction, let's say that like this is the initial phase, and in the phase displacement one that we were just trying to apply some uh, line displacements over here. And after this particular line displacements, I asked you to do some kind of excavations for this particular problem. Okay, while this particular displacement is there, I would like to do this. So now I'm just selecting this one, add one more phase. So that means the input for phase 5 is something like the displacement phase. If you have any confusion about this particular lining, so double click on this particular phase 5, go to general, to the phase 5, start phase is the initial phase. You can see this. This is the phase 5, I'm solving it. And the start phase is the initial phase for this. Okay. Now, so the start phase is an initial phase for this. So now what I did, I just try to deactivate this particular soil now. Try to deactivate this particular soil. And now I don't want to solve all these things. So I can just mark it. I want to solve only these three. Okay. So now let's calculate this. Ignore this particular feedback and I'm just calculating it. Now, if you see, this is where the displacement problem it was solving it. And please be observed that every time when you are solving it, you have to watch about the end stage and how the stiffness is varying. And if you are applying the displacement as an input, you can see the force values also over here.
I have one question.
Yeah.
So, do we need to prepare the bore log for this or no?
Bore log is already prepared, no? In the last.
Long back we have prepared.
Yeah, the same thing only we are using. The old design itself we are using.
Okay, okay. That is where I got confused. Okay.
Okay, now the displacement was applied successfully, where the force was reached up to like 80 kilonewtons. Now it was trying to excavate that particular part. Now see the values actually, M stage value. Observe the M stage value where it is going to fail. 30%, 37%, 45%, 50%, 59, 60. Is that full excavation is happening? Around some 60, 65% of the excavations, it has been done. Okay. Let's say that if I double click on this particular phases, now I just got it to know, I just got to know from this particular phase actually, soil body it is collapsing. That is what is actually the error that I got to know. So now when soil body is just like collapsing over that particular phases, now I would like to know, go and click on the results, view calculation results if you can click. If I click on this particular view calculations, put control 2. Okay. Now actually what happened, this is my initial phase and this is where only the displacement it is applied, and I applied a 0.05 mm of displacements, and because of the software tolerances it will goes up to like 0.056. And then this is the phase 5 that we are just applying this excavations. And if you just see these particular excavations, the maximum value actually it went up to something like around 0.32 or something. And the M stage value, that when I look into this particular M stage value, it was failed approximately around like 0.65 or something like that. Okay. Now let's say this, I'm just going for calculations. Okay. Now I have given a depth of like around 1 meter, and that into 0.65 will gives me like 65. That means 0.65 meters of the depth it could able to do successfully from my understanding, and the remaining zero point 0.4 0.35 whatever it is there, that particular part it is causing you a problem. Why that is causing you a problem is like, if you just look into this particular contour, this side it is getting collapsed, this side it is getting collapsed.
Yes, yes.
Okay, so now what I understood from this, after doing up all these particular things, I observed like it's failing at sigma m stage of like 0.65, and then I realized it. Let's do this particular excavation, not the full part. Now I will just go create a line, and then I would like to, yeah, when you have these issues, you can. I would like to
What?
do only half of that particular thing. Now the half of that is like minus 0.5, and here also it is like minus 0.5. Okay, so now I would like to do only the half of this excavation. Now you just go for the mesh again. Now generate your mesh. Now go to your stage construction. Now you don't want all these things, so you can just mark it not required. And then in this particular phase, when you are going it, you are going to excavate only half, only this much you are going to excavate it, not this one. So now you can start calculating this one. That is what is my first observations.
It didn't
So
fail last time.
it failed at 0.65.
0.5 didn't fail.
That's what I realized that it is like up to 0.565, and then I'm putting it as like a 0.5 now.
0.5 didn't fail last time. Based on
It
the
won't
contours.
fail. It won't fail. That is what actually the software is telling. How I come across this particular 0.5 is a Vivek question. So how I come across is like my sigma m is showing me like 0.65. Instead of 0.5, you can go to 0.6 also. It won't fail. But I don't want to take that particular risk. So I just stopped at 0.5. Nearest round figure that you can do that. That's it. Now let's say that sometimes it may fail also over here, but let's see that. Now it's crossed like 70, 80%, 90%, and then it got failed it actually. Okay, so it says I'm nearer to that, but still what is happening here? Now, if you just go and look into this particular results here, now again I realized one particular thing here. If I just look into this, this is where like I requested for point 5 meters of depth, but it has been went up to like point 9% actually. That is like M stage is like 90%. Okay. How do you come to know that the M stage value is something that you already know that the graphs? So you can just go to the graph. You can create it by chance if you didn't see the M stage value. So go to the project, multiplayer, click on this particular M stage, and then on to this particular thing. If you want, you can just put it something like force. Okay. You are excavating it for that how much amount of a force you required. Even that is also you can able to tell that from this particular graph. But now when I just click on this particular thing, it gives me the whole thing. So I'll just go to the settings over here, onto the curve phases, where I would like to select only this particular phase. Okay, apply. Okay. Now if you see this M stage is stopping exactly at 0.885, that is near to 0.888. 88% of the load, I mean 88% of the excavation can able to do successfully, but remaining thing it could not able to do that particular thing. So this is where, so now I understood 0.5 meters is the excavation that I have given it. Out of that, like it could able to pass like 88%. So that means it could able to do only 0.44% successfully. 0.44 meters it can able to do successfully. So now I realized it. I came back here to my structures module. Now I would like to do my first excavation as like 0.44, or if you want, you can just make it to a round figure, always suggested. Just like -4. Now you are done. You are going to the mesh again. Now you can generate the meshes and go to your stage construction, and the remaining analysis is not required for me. So you can just do this. Now this is an initial phase, and now it is calculating the displacement. After applying the displacement, and then it will start for the excavations. That means after the after placing your foundation, then you are going for excavation. Okay, now you can see. Oh, sorry. When I just click on my, yeah, okay, it got excavated. Yeah, fine. This is initial phase, load applied, and then it got excavated. Now you can click on this view results. Now you can see that the excavation is also done successfully. So for this particular conditions, at a time, I can able to go up to like 0.4 meters of excavation without any kind of a supports. But if you start installing the supports, then you can go deeper and deeper and all. So those particular parts and all, slowly we can start working on that. Okay. Now, is it clear to all, like what exactly we try to show here?
What is the basis of selecting 0.65 initially? Rest of the things are very clear.
First, actually, when I did it for 1 meter, it got failed at like 0.65%. And when the sigma
Okay,
end stage
okay,
is like
okay,
0.65.
okay.
So then I
Okay.
realized that maybe 0.5 it can solve. So when I go for 0.5, then even 0.5 is not solvable. So it is
मतलब
solvable.
basically trial and error we have to apply, no?
Okay, okay.
Yeah, trial and error that you have to apply. But for that, there is a thumb rule that you can stand within 1 or 2 trials that you can come up with the right solution.
Okay.
Based on percentage of failure.
Yes, based on the percentage of failure that you have to decide.
Wonderful. Thank you. Thanks so much.
Is that clear, Vivek, now?
Yes.
Okay, fine. Okay. So please be remember that when we are seeing an option, I want to hint you from now on. When we are seeing one particular option, it is not useful only on that particular solution. It can be used anywhere, only the out. Okay, let's move on this. So now this excavation part that you guys were able to do it successfully. So from this, I understood that no one has been done this, but try working on this. Now to this particular problem itself, let's say that you're telling that this is the displacement that I have applied it. Now to the displacements, I've just applied add phase, one more phase that I'm adding it. And to this particular phase, actually, I can say instead of a plastic, I can say it's like a safety. I thought of covering consolidation and then come to safety, but you guys are little wanted to know more about the safety. So where there is not having any dependency, I can cover this. So the safety, I can select it. Just give OK. Not required to select any other things. You just click only on safety. Okay. Now you just go and calculate that. Only the safety analysis it's calculating now. And on to the safety analysis, actually, you should not rely on the displacements actually it was showing it. Okay, let's see that. We will see what was the safety analysis. Now, when you just click on this particular safety analysis, now actually, if you just see these particular things, the factor of safety, it reached around like some 15. Reached factor of safety is something like 15. So that means you can assume that how strong for 0.05 mm of a displacement, it was very, very much strong enough for this particular thing. So still it can capable also when it is like a direct soil kind of a thing. Okay, so you can, so the reached factor of safety is something like 15.08 for this. But if you apply this particular load, then you're going to see a more and more values and all. And for this, actually, if you just go for the view calculation results, the safety analysis is like a little tricky analysis, not so very good recommended all the times. And when you just go for this control 2, now you can see this actually, the maximum value of displacement is something like around 0.08 meters it was telling. So maybe you can just go, but don't be stick on to this maximum value all the time. So, but you told that like you are reaching about like 0.05 is your input, but it can be capable of taking up to like 0.08 meters of depth actually. So that's where it goes. And now when you're just trying to plot this particular safety analysis, so to the curve actually, just give a new curve again. And now onto this actually, if you would like to go on the x-axis or sigma MSF. Sigma MSF is nothing but your safety. Sigma M stage is nothing but your input. Okay. Sigma MSF against to the force that it is applied. Okay. Or like to the displacements that if you want, sigma MSF versus sigma M stage, you can say. Sigma m stage is nothing but your displacement, because that is what the input number, right? If you give 10 meters as a displacement, and that is, okay, here it is considered as a 1, so that means 0.9 means it's a 9 meters, like that. Okay, now sigma m stage was a sigma msf, sigma msf was a sigma m stage. I'm doing it when I just give okay for this. Now see these particular things. This is where like sigma m stage, it is going to 1 when actually the situation is something like over here. Actually, if you see this sigma msf, factor of safety is something over here. So the factor of safety is 15 point something. So the value you can show that. And this is a sigma m stage. Sigma m stage for your 100% of load. So the load that you've given, the factor of safety that is coming is around 15. So that's where actually keep on it is showing it over there. But if you would like to go for a best fit actually, so this is where sigma msf actually, you can just go and see this. Now you can see at that particular point of time, sigma msf is 1. If you just look into this, sigma msf is 1. What is it won't stand over there for a long time. Yeah. Oh, sorry. It's my mouse for. But you can see the values right now. Yeah.
Yes.
Oh, okay. Now, if you see the series curve, sigma MSF is 1, and then sigma M stage, it was showing that like a 0.992 at that particular point of time, actually, sigma M stage 0.99, that is equal to 1. So at that particular point of time, it was very much clear. Okay, you were like confused about this particular things. Click on the tabulated values. Now we are going to get for this. Okay, so now sigma MSF is 1 for all these particular things. Sigma M stage, when you apply M stage is nothing but your displacements, right? So for all your displacement, sigma M stage is like factor of safety is like 1 at that particular point of time. Okay, sigma MSF actually when the sigma M stage is something and all, so in that particular points you can able to look into this and then you can understand it better. But this is a one particular thing that you can able to get it. So you can now you can able to see these particular values actually. So you can just go to your extreme values. What I showed you is an in detail curve, but if you would like to go for an extreme value, this is where your factor of safety of like 1.6 or 1.9 or 1.2 if you are looking at. So the 1.2 actually when there is a no load applied also the 1.2 factor of safety if it is reaching it, which is doesn't make sense actually. Okay, so don't be rely on that. And coming on over here actually, when you applied for this actually, this is where like 15. So that's why I told the displacement, it is like a little tricky analysis where end stage you don't be relayed, but the displacements you go not only in this particular problem, in an entire plexus, the supporting axis for safety analysis is always a wrong values. So that's where like an extreme conditions I can take it, and this is what actually happened. The maximum value it can go up to like 15.084. Okay, so let's say not this, not this. You are not calculating even let's say you are not calculating this one, you are not calculating this one now, but let's say that you have a flexible footing, and in the flexible footing that you have at something, and to this particular flexible footing that you are adding a one more phase. In this particular phase I'm just calling it as a safety analysis. Okay, now this time actually you are applying the load. Okay, now I'm just trying to solve this too. Now see this M stage is always 0 over here. for if you are running a safety analysis, M stage is always a 0. It will never vary. Okay. Now when I just click on this particular safety analysis, now when I applied a load actually, so for that particular amount of a load, I can say that 1.168 is my factor of safety. That means like to the applied load into like 1.168 of the maximum you can go. Let's example I can tell that when I just go for this particular things and when I just go for a line load, I have applied like 188 kilonewtons, right? So now this 188 into 1.16 gives me like 218. So that means without getting any soil body collapse error, I can able to go till 218 kilonewton per meter. And I'm telling right, this is not always correct. You can just consider it as like 0.05 deviation. That means like you can 218 minus 10. That means you can try up to like 208 kilonewton per meter. It should work fine. It should work fine. Okay. Now let's say that instead of 188 minus 208, I'm just keeping it. Okay. Now the same problem, I would like to recalculate it now. I'm telling you the importance of like safety analysis when you apply a displacement and when you apply a load, how it is varying it. But this is not the right example, I'm telling you. For better understanding, this is not the right example for safety. But still, if you guys are wanted, so please be stick on to your load placement, why it is showing something like that or not. Stick on to only the load case. Yeah. Now, if you just go for this particular load case, now I can see that the factor of safety before it was like 1.6. Now it has been reached up to like 1.129. So that means I have applied around like 208 by considering my, by considering my tolerance also. That was like 208 into 1.12, right? Yeah, 129. So it's almost 13, you can say. 208. So sorry, into 1.12. So actually it was telling that it can be capable of up to like 232. Okay, let's see that previously it was telling about like 218, but now it was telling about 232 when we just increase the load. Maybe the soil got compressed it and it got have a well settled at that particular position. Previously it might have some loose in nature, but now it has been get compressed it and it may gain some stiffness also at that particular point of time. Okay, as I told, like let me do that like 232 minus 232. Okay, let's do this 232 that we were just trying to solve this. Now again, you can just solve this particular problem. Because it shows that factor of safety is that, and you were just trying to solve that particular problem at that particular factor of safety, whether it is really good or bad, or it is failing, or it is passing. That's good. Till 232 load, it got passed successfully. Now the factor of safety previously it was like around 1.3, right? Now it may come down to 1.1 or 1.15 is what I'm expecting. Let's see that. See, 1.1 I'm expecting. It's like 232 is the load that I applied it. Now 232 into 1.106. That is the finally it says that it is like 256 is the load when the soil position it is keep getting compressed and compressed, and then it is finally taking up that particular load. So based upon this particular factor of safety that you have to figure it out, you have to do the trial and errors also here to get your exact bearing capacity. But you can say this is what the limit But if you really wanted to say that there is an analysis called as a limit analysis, which Plaxis will not support for that. For that, actually, Geo5 or Optum G2, these softwares, Optum G2, yeah, Optum G2 will support you actually. That's one of a very good software. I can say an equal competitor to Plaxis. I only introduced that in India. It was an Australian-based software. So the first user is also in Chennai for marine industries and all. Yeah, there you can do the limit analysis, and it was specially designed for foundations. It was designed specially for foundations. So you can go up with any foundations and then you can come back with these particular values. But you have to remember this. This is a finite element analysis always that you are doing it. So it will never tell you that, okay, this is what is the exact point that you have to look. It will tell you a nearest point that you have to look. So that is where your experience will come in picture, and then it will tell you that, oh, okay, this is what actually I need to finalize it. Now, if you see this, it is all like 1.106 that's coming after applying 232 and 256 if it is coming, right? So let's say that if you would like to go for 256 again, can you guys guess like what would be the factor of safety now?
1.17.
It would be near to 1 or 1.0, something like that. But again, I'm telling this is not the right example for safety analysis. I'll come to you and I'll teach you that how to do that. Yeah. Now, if you just go over here, this is 1.06. 06. That is, I can consider it as a 1. So that is like 256. Okay. Now I realized it. Okay. So let me go 256, right? So let me put it as something like 280. And then I'm just trying to solve this. To the amount of load that you applied it, based on that, it is going to calculate the safety factor, and then it is going to give you an information. See, the solution got failed it actually. So it cannot able to take that particular 280 load. So whereas like 256 that we will reached it. So it is like exact the thing that it can go is something 256 into 1.06, I can say. 283 actually it was showing it, but when I just go for 280 itself, it was failing that. So you cannot, it will show you a nearest value, but it will never be stick on to an exact value. This is what actually, because it involves so many parameters. So from here to realistic goal, people will consider a deviation of 15%. 15%, because you can't simulate the nature exactly as what it can be. Okay. So the best thing is like for this particular problem to consider up all these particular things. So whatever be the best safety factor that you have to follow is like above 1.2. If it is there above 1.2, then only please consider that that is a valuable input for you. But if it is like below 1.2, please don't consider that as a valuable input for you. Okay. If your factor of safety is something like, when you just go for again, like 188 you are going with. So when Why? Okay, when you're just going for this particular 188, so for this particular load, and when you're just trying to solve this particular safety analysis, then it should show something around like, oh, why it is taking it as 280. Cancel. Now you can solve this. Now, if your factor of safety is coming above 1.2, you can consider that is some good value. But if your factor of safety is something coming below 1.2, by considering up all the natural conditions, that may not be the right factor of safety. So that means in realistic, if you want like 1.2 as a factor of safety in classes, that you have to relate at 1.4. 1.168 is the factor of safety for showing it. Okay, 188 to the 1.168 also, that's a good value, but I can say that it's nearer to that only. I always recommend that please be considered that at least 1.2 above. So that is always a good healthy environment and a good design, you can say that. Okay, sometimes it can be a over design also, sometimes it can be a over design, but you have to be, depends upon the situation to situation and soil to a soil, because each and every soil is not going to be stick on with the same thumb rule. Is it clear, the safety analysis?
Yeah.
Yes.
Okay, fine. Good. So now you start doing this, the excavation problem that we were discussing about this, right? So now for this particular problem itself, let's say to the structures I'm going here, and to the structures that what I did, I just inserted a plate element. Okay, I was just inserting a plate element like this. Let's say this is your sheet pile. You can consider your plate element as your sheet pile also. Okay, and to this particular plate element, I was applying the same properties of like foundation. In reality, it will not be like that, but just assume that I'm just applying only the properties of this. And then I'm going for a mesh. Here the depth also roughly I draw, okay? Not nothing particular on that. I just drawn very roughly. So if you see this in the mesh actually now, when you are working on this more structural elements and all, this is where green you can see. This is where green you can see. Why can't you see the green over here actually? Because this is a part of a plate element. Over that actually the line is also overlapping here. So that's where I would like to go for this. So now select, if I select this one, the coarseness factor is 0.25. So now click on this, make it as 0.25. Now click on this, and this also just make it as 0.25. Now on the other side also, so it's a good habit to maintain always. In between also you need it when you are doing a submerged excavation, but right now it's not needed. Okay. And now going for the flow condition instructions. Now onto the phase 5th, I would like to deactivate this particular part also. That means at a time I want to do a 1 meter depth, but I would like to activate this particular plate element. So the plate 2, I would like to activate it. So the plate 2, I would like to activate this particular things. Okay. Now I've just inserted this particular things, and now I would like to do. So the displacement I can apply. Phase 1 ka input is like directly this one. Okay. So now not required, only the excavation I can do. Phase 1 ka input is like the initial phase. So directly I'm doing this particular excavations. Now you try to solve this. Previously we used to fail over that particular place, but now as we added a support, I feel that we are going to pass now. Let's see that. If we failed it also, how this particular support is not helping us, even that particular results also we can able to see it now. Previously we failed at 0.65. Now we reached up to like 70%. That's good. Still the graph is going constantly, so no issues. You can see that here you can see this particular graph actually. Suddenly if there is any up and downs and all it's happening, then so it's going stable now. That means soil is getting stabilized it. It's not failing, but it is getting stabilized it. So that's why you can see that sigma m stage is not changing anywhere. So it was trying to identify a solid supporting equation at that particular point of time. Now, after identifying that, it is doing it very, very slowly. So that means a lot of damage is already happened. That's why you can see the stiffness is also very less. And then it was trying to identify the solution. It was trying checking for the solution. It's not failing it because there are like multiple iterations it is trying to solve it. Okay, but it was just trying to look into that particular things. Oh, Jayashree is joined just now. Hey, hi Jayashree. Sorry for you actually. Today we thought of doing at 7 o'clock and completely my badness. I could not able to inform in your group. So now see this guy is actually some problem with my Teams. Yeah, I can see this. It was all trying for this. Now actually the convergence is not happening at all finally, and then it got failed. Yeah, that's good thing that why it is getting failed that we will see it now. So now if you just go for this view calculations, previously it was failing at like 0.65, but after adding a support, I could able to reach up to like 0.77. Now, when I just look into this actually, I realized this. The problem is not happening on this side. The problem is happening on the other side actually. Okay, so now you can see that the complete deformation that is happening over here. The max, it is trying to collapse it in this direction. Okay, now that's also makes sense for you. At the other side it is failing. So now I'll just go create a plate element onto the other side also. Now you can assign that particular plate is also like a flexible footing. Go for the mesh and make sure that everything is in green, the marked regions for you, and then go generate the mesh. Then go to the flow conditions over here. Yeah, nothing to work under the flow. Now I would like to stop all these things. I wanted only this. So this is the complete excavation where I would like to activate the other plate also. Now the blue color, it indicates that it is activated. So please be make sure in the model explorer that you have to go to the plates and make sure. So now this is plate 2 is this one. You can just, yeah. Plate 2 is this one. So activation and deactivation, you can see the change in colors. The gray color to the blue color, it is coming. Okay. Gray color to the blue color, it is coming. So you can see this. Now I would like to solve this particular problem. So now the other side is collapsing. That's where that we have seen. That's where like It search for the stability. The other side, if there is any support, it is coming or something, nothing like that. With one side support, it try to verify that, but still I can't see that something. So then it move on to the other side. Okay. The beauty with the sheet piles for these particular supports, I enjoyed a lot in berth constructions actually. I've supported to a few clients in Europe when I was with Ramcadis itself. So that particular time, yeah, that was a very much interesting things where like multiple pressures are coming onto this particular sheet piles, and then you have to bear that particular things and design for that. One side only that we are going to add for that. Your diaphragm walls can do it on one side. See, after
Sir, I have
getting
to
that,
enter. I have to attend another lecture.
yeah, sure, fine.
Thank you. Thank you.
Okay. So now it's about like 0.75. Previously, we have seen around 0.77. But the curve is quite good actually. It's not at in a horizontal way, it's coming down. And the stiffness is also not into the negative values. That's good. So now it starts getting stabilizing for that, like, okay, it got failed after adding the other support too as well. Now go and visualize the results. After viewing your results over here, you just see this particular things. There is a no or nothing, but actually still that you were able to see some kind of a failures over there. Okay, let's see that in the arrows directions, that if you want it, you can see that a lot of pressure coming on here, a lot of pressure coming on here, and a few pressures it is coming, but still you are feeling it. Now you have an option actually. So that is where actually how much actually this particular plate elements got deformed it, and what is the strength, and what is the shear force and bending momentum of this particular plate element. Yeah. Now you just go and double click on this particular one plate. Double click on this particular plate, and then here you can see that what is the diagram that you can able to see over here. And you wanted to see forces, you just go for this shear forces. This is where the shear force diagram of your plate element on that particular side, and this is where your bending momentum diagram of that particular plate. So from this you can able to understand it and realize it, whether you need to increase the strength of your it's not here like now the depth, you have to increase the strength of your particular plate element on that particular point of time, or what exactly. So you can just make up your own decisions. It's all completely up to you. So the software will give you a decision up to this, or it will show you the results. Now you have to realize it, whether I need to increase the strength or I need to increase the depth. So you can just make a note of this particular thing. So this is where, suppose if you would like to see the other things, so you can just go and click on this particular plate element, and onto this particular plate element actually, okay, onto this particular plate element. And when I just go for this particular forces, so this is where the bending momentum diagram, and this is where the shear force diagram. Okay, now I'll show you one beauty of this. Close this. My particular problem is failing it over here, and when I just go for my material properties, this is SAN 1.1 edit, I just gone with drain conditions. Okay, let's say that I just go with the like undrained A conditions over here. Now tell me guys, you already know what is an undrained A behavior, which gives you a like a full effective properties, both the strength and stiffness. And then it is also going to calculate the extra pore pressure calculations of that. So with this actually, will this particular excavation will solve or it will not? Can you guess and tell me that? Guess anything, whether it is wrong also, no problem. You are going to learn the reason why it is wrong.
I think it would fail because it is a short-term behavior. It has short-term behavior.
Exactly. It will fail actually. So that's where you see that previously the problem is solving around like 0.7 or 0.8 percentage, and then it is going to show some kind of a stability issues over there. But now for you actually, from the very beginning itself, the stability issues are coming up. Though your problem solved successfully in this particular case, there is something wrong with your solution. Okay, that you have to justify it yourself, but not all the times. Okay, now let's see that what is going to show that. Now it's already done, the excavation part, everything is done. How the forces are varying it, I'll show you that. Okay, now when I just go for undrained A conditions, to be honestly logically reason that is not the right way, but we are supposed to follow this particular things, and then it passed it. Why it got past it, I can show you that. When you just go for your results here and put control 2, and if you just go for this particular phase 5 displacements actually. So now if you just see these particular things, okay, I would like initial phase is this one and this is the phase 5. Okay, let's see one thing. So phase 5, the line displacements are also activated. That's why I can't see a right thing. Okay, I will switch off the line displacements and then I will look for this. So when I just go for this, actually what will happen, because of this particular excess flow pressure conditions, this will pass. Why this will pass is like, if you just look at this particular results, let me take you a snapshot of this. Your soil will get start building an excessive bulk pressure over here actually. So that means because of its pore pressure conditions, when you're just trying to push it up, will always try to create a expansion like this for your soils and all. So because of this particular expansions, an additional support will come to this. That's the reason it is passing. But when you just in a deeper study of this, the curve is almost all horizontal at the line, so which is not a good nature, as per FEA. So please be remember that guys, the material properties you selected, always if something is coming correct, it is not always correct. You have to be very careful about all these things. Okay, let me do one thing again here. And now in this the line displacements, I deactivated it. Let me solve this again, so that you can see that particular bulge in conditions a little. Maybe for this particular role you can see it or not, I'm not sure. Okay, now see this thing. It got solved it very quickly because of there is a no load, nothing. But this actually in the drain condition also it will pass. But you can see this one. So when you just see this particular things, Okay, when you just see this particular things, this is like an undrained A conditions. Okay, let's be, wait, come on. Okay, let me capture this particular image. Now close this one, go to Control M. For this particular sand itself, you can just go and change to drain conditions. Okay, now I'm again trying to solve this. Sorry. Now you see that the graph is coming down a little because of the lower stiffness. Now it's getting like stabilizing the solutions over there. It's searching for the stabilization. That's why the aim stage is not at all moving. You can see that. And now it's got failed. The same solution. And drained conditions, it got failed. Why? Its behavior, because of its excess pore pressure conditions, of its effective excess pore pressure conditions, it is supporting actually there. So now let me view the results here, as it was failing for that particular excavation. Okay, now you can see that that particular curve itself is not there. And when I just go for this particular things also, okay, so this is where actually the behaviors, you can see this, guys. When I just go for this particular image and to this particular image, can you see the differences? Okay, can you see the difference here? Which is more realistic? As the soil it is pushing out over here, it is slightly bending here, and here we don't have that much of a bend, but still it is like to be a supporting. But here, because of it's clearly able to pass this particular solution. So my idea of explaining you this is like selection of your material drained model also will plays you a major role. It's not simply that you can pick this and you can start working on this. When you get some results, you should be in a position to understand that particular contour really makes sense or not. Okay, so with this I would like to pass here. If you have any questions, we can discuss. Any questions?
No.